Welcome to Homework Lib.
Chapter 14, question 36. They're giving us a reaction and the data regarding the reaction, and they're asking at A, what's the rate law for this reaction? Now, first we need to find the rate law of the reaction. To be able to do that, the best to pick experiment 1 and 2 to determine rate law for NO, because O2 is not changing at these two. 0.0252 divided by 0.0126 of NO. There's of course a K over here, but we don't need to care about this K because these two experiments, the K's are going to cancel each other anyway. And this is going to cancel each other too, so I'm not going to include the O2. And this will be equal to 5.64 times 10 to the power of negative 2 divided by 1.41 times 10 to the power of negative 2. Now, there's a power of m to NO's term, and we need to find this power of m to be able to understand what order this is with respect to NO. So what we get from here, if we make it simpler, it's going to be 2 to the power of m. That will be equal to, it's going to be 4 times bigger, 4. So m is going to be 2. So the order for NO is going to be second order. What about O2? If we pick 2 and 3 to fix the amount of NO and double the amount of O2, so I'm going to simply write 0.025 divided by 0.0125 of O2 to the power of n is going to be equal to 1.13 times 10 to the power of negative 1 divided by 5.64 times 10 to the power of negative 2. Now this is twice as much of this, so I'm going to write 2, and this is twice of the other value, so I'm going to write 2 here. 2 to the power of n would be equal to 2, so n equals to 1. So it's first order with respect to O2. So if you want to write the rate law, it's going to be K times NO to the power of 2 times O2. B, they're asking what's the average, the unit of the rate constant. Now, the unit of rate constant, what we do is, the rate is concentration over time in seconds, and that's equal to RK times m squared, this is a concentration, and this is a concentration too, times m. So what we're going to have is going to be m over s, and these two terms, m cubed equals to k, and this is going to give us 1 over s m squared. Let's say this is B and this is A. So at part C, they're asking us the average rate constant calculated from 3 data sets. So what we need to do is, into this term, we need to just write all these values. Get this value over here, get this value in here, and all these are going to be equal to the rate value. And solve for k. Once you do that, we're going to find 3 different Ks. Let's say K1 plus K2 plus K3 divided by 3. And you find the K to be, let me quickly check my notes, 7109. At part D, they're asking us what's the average rate of disappearance of NO when NO is 0.075 and O2 is 0.01. So basically what we want to do is we want to write these values into our rate law over here and find the initial rate. So as we do that, the number we come up with is going to be 0.4 once we get these values into our rate law. But 0.4 is not the rate of disappearance of NO because this is our reaction. And the rate of disappearance of NO is going to be twice as much of the rate of the initial rate. So if you multiply this by 2, it's going to be 0.8. Now, how we get this number is because there is 2 NO. What is the rate of disappearance of O2 at the concentrations given at part D? So at the concentrations given at part D, it is going to be just O2. So the answer is going to be 0.4, 0.8 for NO, and 0.4 for O2.